In this video, we will go over section 4.5, the average cost. Now, recall that the marginal cost is the cost per item at a particular quantity, and its units are usually in dollar per item. Now, the marginal cost has no memory or history. It only adjusts the cost of increasing or of the quantity by 1 unit. So if you increase the quantity by 1 unit, how much you have to spend more to make that items. Now, in this section, we learn about the average cost, or the cost per unit of producing certain quantity. So let's write out a definition for this one. So the average cost is the cost per unit of producing certain quantity, and we usually define this by the symbol A of Q, right? A stand for the average cost, and Q stand for the quantity. So the average cost is equal to the total cost, C, also in terms of the Q. So the total cost divided by that number of quantity, or you can say total cost over the number of the unit. Okay, so let's go over one example, and hopefully it will make sense. Now, if I have the total cost equation, C of Q, the total cost equation of producing certain product to be 0.01 Q to the third power minus 0.6 Q square plus 13 Q and plus 1000. Now this total cost, the units would be in dollar, right? Now the question, if we know that 100 items are produced, now what is the value for the average cost? So the average cost equal how much per item. Okay. So if you take a look at this function again, the average cost is equal to the total cost divided by the number of the unit. In this case, we have 100 items or 100 units. Now, so we just need to find the total cost of this much item and divide by the number of the items. So I'm gonna find C of 100 because where we have 100 items. So C of 100. If you plug in this 100 for Q in this equation, you're gonna get around 6,300. Therefore, you can find the average cost for 100 items should be equal to C of 100 divided by 100 items. We have 6,300 over 100, and it should give you $63 per item. That means for producing 100 items, each item has the price of $63. Okay. So when we are producing some items, we always want the cost to be as low as possible, right? You don't want to spend too much time for producing some product with high prices. So the question comes to the point that we have to find a way to minimize the average cost. So minimizing the average cost for the next topic. Now if I have this example, I have the total cost C of Q 1000 plus 20Q. Now the question asks, find and compare the marginal cost, which is MC, to produce the 100 item, and the average cost of producing 100 units. Okay, so we are given the total cost equation here, and we want to find and compare the MC, or the marginal cost, to produce the 100 item. Okay, so how much does it take to produce the item of 100, and also find the average cost for producing a total of 100 units. Okay, so if you take a look at this cost function, we have a constant plus some variable multiplied by 20. So this indicated that we have the fixed cost of 1000, right? So even if you don't produce any item, so Q is 0, we still have to pay 100. This is the fixed cost, maybe for the renting or buying the machinery or hire the employee. So this is the fixed cost, and the variable cost is 20. So each item is $20 more. So the variable cost should be 20, and the fixed cost is 1000. Okay. So in order to find the marginal cost, or MC, remember the marginal cost is the first derivative of the total cost. Okay. So if you just want to find the marginal cost, just take the derivative of the total cost function. Now this constant, when you take the derivative, it's gone, and 20Q, it will give back you just 20. Okay, or you have $20 per unit. That means the marginal cost, the cost to produce one more item, is $20. Okay, now let's find the average cost. So the average cost of 100 item equal to the total cost of 100 items over the total amount of the items. Now if you plug in C of 100 for Q, we will get 3000, because 100 times 20 gives you 2000, plus 1000 is 3000, over 100 gives you 30. So $30, this is in dollar, this is in units, so dollar per unit. Now you compare the average cost and the marginal cost. The average cost seems to be higher. It's $30 for each unit, but the marginal cost is only $20 per unit. The reason that we have the higher price for the average cost, because we include the fixed cost when calculating the average cost, and the marginal cost we didn't include that. When we take the first derivative, this becomes 0. Okay, let's go to another example. Before we go to this example, remember that the average cost, we have the form of C Q over Q, right? And we can rewrite this as CQ minus 0 over Q minus 0. This is the same thing, nothing is changing. So we can visualize the average cost as the slope of a line from the origin to the point Q and shift Q. So we can, this is the same thing as the slope of a line from the origin to the point Q and then shift Q. Okay, so let's go over this example. Hopefully it will make more sense. So I have the graph of Q for quantity, and this is for dollar. Now, if I have this graph, okay, this is for the total cost. The question asks for which Q the average cost minimize. So when you try to produce the item for your company, you always want to have the low average cost as much as possible. Now, so we are looking for the number of units that does have the minimized total cost. I mean the average cost, right? You want to minimize the average cost. So remember, the average cost is equal to CQ over Q, the same thing as this 1 minus 0. And this is actually the slope of a line from the origin to the point Q and shift Q. So if you are looking for the minimized average cost, this is the same thing as you are looking for the point on the graph from this graph to the origin, and it has to give you the smallest slope, because this thing is just the slope. So we are looking for the smallest slope from the origin to the graph. So if I randomly pick a point here and I connect this to the origin, this is the slope, right? If I pick this point here and I connect this to the origin, this is also the slope, which is the average cost, and we want this to be minimized. So we have to find the point on this curve where the slope is smallest. So this point, of course, is higher than this point because this is the slope is more steeper, and here is smaller. How about trying this point? Yes, of course, this point gives you the smaller slope comparing to these two. Remember, if I have horizontal, that means zero slope, right? And then increasing, right? And then if it's vertical, that's undefined slope. But therefore, this one is smaller than these two. Now, it's still higher. Let me pick this point. Okay. So let me draw this graph. Yes, so this point is, of course, the angle is smaller than this one. So this point is smaller. How about this point? Okay, let's connect this point. Oh, this point is now become higher, and then again this point, same thing here. Yes, it's higher. So it seems like this point is the smallest, because as you go up here, it becomes steeper. As you go down here, it also becomes steeper. So around this point here, we have the smallest slope. So this will give you the minimum average cost for this Q, right? What about the value Q here? Should give you the mean average cost. Alright, because the average cost is just a slope from the point to the origin. If you visualize this as a slope. Okay, let's go to another example. I have 100 items are produced at an average cost of $2 per item. Okay, so find the average cost for producing 101 item. If the marginal cost to produce the 101 items A is $1 and B is $3. Okay, so we have 100 items to be produced at an average cost of $2 per item, right? So now they ask us to adjust or to find the average cost for producing 100 items. I mean 101 item, 100 and one more item, and they give us the marginal cost to produce that extra one item after 100 item. A is $1 and B is $3. Now let's find the total cost first. We know that two items, $2 per item, and we have 100 items. So that means we take 100 multiplied by 2, give you $200 for producing 100 items. Now, if we have one more item, then we take $200 for 100 items. We plus the extra 101 item, which is $1 for the marginal cost, and that gives us 201 for the total cost. Now, after we have the total cost of 101 item, right? This is equal to C of 101 over 101. Now, the total cost for 101 item is $201 and divide by 101 item. That gives you $1.99. So this is $1.99 per item. Okay. Now we do the same thing here. Again, the total cost for 100 items would be $100 multiplied by 2 is 200. But now we have one more extra item. We take what 100 item cost, which is 200. We plus for $3 for the extra one item after the 100 item. That gives us 203. Therefore, when we find the average cost for 101 item, we have the total cost is 203 divided by 101. That gives us 2.01. This is dollar per item. Alright, so let's go to one last example for this section. Now example. So we are again given the total cost function to be C of Q is equal to Q to the third power minus 6 Q square plus 15Q, and Q is in 1,000. So if I have Q equal 1, that means 1,000. Q equal 2, that means Q is 2,000. And the range for Q is from 0 up to 5. Now the first one, they ask us to find Q. That's minimize the average cost. Okay, so Q is the quantity or the number of the items. So we must find how many Q we should have in order to minimize the average cost. So if they ask us to find the minimize average cost or the mean value of something, again this is the max and min problem, or they're just looking for the global max and global min problem. Again, we just apply the same thing that we do to the other section to this problem. So they ask us to minimize the average cost. So first we must have the average cost function. So the average cost is equal to the total cost over to the quantity, or we have this one plus 15Q. Now divide by Q. So Q3 and Q1 give me Q square, and this give you Q and Q cancel, plus 15. So this one is the average cost. Okay. In order to find the Q, to minimize this A of Q, we first find A prime, which is using the power rule, print out a 2 and minus 6. So find the A prime and then set that equal to 0 to find the critical number. So 2Q equals 6 or Q equals 3. So Q equals 3 is your critical point. Now, which is the point that you will minimize the average cost. Okay. So Q equals 3 or 3,000 units. And part B, find the marginal cost. Again, the marginal cost is what? It's just the total cost function, take the first derivative. Now your C of Q is here, so apply the power rule, take the first derivative, so bring down 3, subtract 1 from that, and bring down 2, subtract 1 from that, so 6 times 2 is 12, and plus 15. So this is the marginal cost. This is the value of Q that gives you the mean value for the average cost. Now, if I graph this on the XY plane for the average cost, so I graph the this is the C of Q. So this is 1, 2, 3, 4, 5, and so on. So 1, 2. So at the point 3,000 here, we have the mean for the average cost. Remember, the average cost is just the slope from the point on the curve of the cost function to the origin. So at this point, gives you the mean value. If you have this point, it's higher, right? It's higher. And if you even have this point, it's also higher. So only this point gives you the mean slope or the smallest slope on the curve of the total cost. So that's how it's, you can visualize this from the graph. So it's approximately equal to 3 for Q. Okay, so that's the end of section 4.5.